Okay, welcome back. So what we're going to be doing is we're going to be going through the solutions for the group questions, the group work questions that were in the Engineering 229 study event. And so the first question, question 1.1, is about multiplying in a loop. Multiply. So we're working with a hypothetical supercomputer that doesn't have the ability to multiply numbers natively. It doesn't have multiply or divide instructions. And so it's up to us to write a piece of code that basically emulates those multiply instructions. So the questions ask us to assume that there's two numbers loaded in R0 and R1. And after the code is executed, R2 should contain the product of these two numbers. So what I'm going to do is I'm going to let the R0 register denote the multiplier, which will be the thing that I'm adding in a loop, and R1 will act as my counter. So the idea is we're going to add 7 to itself 5 times over. And just for good measure, before I run the code, I should ensure that the total is already zeroed out. So how are we going to do this? Well, the counter could be 0 to begin with. So I don't want to do any adds first and then check when to stop. I should check when to stop first. So the first thing I'll do is I'll check whether the counter is 0. So I'll compare the R1 register with 0. And if it is 0, I want to go to the infinite loop end because we're finished. And if we're not, I want to add the multiplier to the total. So add R2, R0. I then want to decrement the counter. So subtract 1 from the counter, and then do the loop again. So sub 1 R1, and then branch to multiply. All right, there we go. So we check if it's 0, and if it's not, we do the add, do the subtraction, branch to multiply, do it again. All right, so let's upload it to the board, and then we'll step through it with the debugger, and we'll see if the code works. All right, turn on the debugger. All right, so we'll skip through to remain. All right, load a 7, load a 5, load a 0. Okay, so we check is R1 0, and if it is, we branch to end, but it isn't, so we don't. I add 7 to the total, so now R2 is containing 7. Subtract 1 from my counter, do it again. Is the counter 0? No. So we add the 7, we get 14, we do it again. Add 7, decrement, do it again. And then this loop will keep executing until R1 is 0. So we'll see that in one more loop. So we do one more add. So we have 5 lots of 7s added all up for 35. And here we go. I compare R1 with 0. Is R1 0? Yes, it is. So then we jump to end, and then I get stuck in the infinite loop here. And you can see my end result here, R2 contains 35. So my program successfully works. It does indeed implement multiplication by adding in a loop.